Hello everyone, my name is Dennis Gomez and today I will be presenting to you Lab 4, the second hack part 1 of the class penetration testing and risk management. In this lab, we use the Keyoptrix level 2 and scan the vulnerabilities of this machine. In Lab 4 Part 1, I identified the vulnerabilities of the Keyoptrix Level 2 machine after performing the Nmap 192.168.56024 command in my Kali Linux VM. I was able to enumerate the Keyoptrix Level 2 with the following IP address: 192.168.56.104. I confirmed it by performing a Nikto vulnerability scan, OWASP ZAP scan vulnerability, and Nessus vulnerability scan. The first vulnerability scan that I used was Nikto. I performed the following command to enumerate the Keyoptrix level 2 machine with the Nikto tool Nikto-H 192.168.56.104. And as you can see, that was the output that the Nikto tool provided and disclosed that all of these were some of the vulnerabilities of the Keyoptrix level 2 machine. We can see some anti-click jacking, X-frame options, header is not present vulnerability. We can also see some cross-site scripting vulnerability, as well as outdated operating system and Apache servers. The flaw hypothesis methodology using Nikto is the following. The definition of the penetration testing was to learn and understand the Nikto vulnerability scanner tool. The background study: I searched for the vulnerabilities on the Keyoptrix level 2 machine in my virtual environment using Nikto-H 192.168.56.104. The flaw generation was done by gathering information by scanning the target host. The flaw confirmation was the following: the anti-click jacking, X-frame options, header is not present, the cross-scripting protection, header is not defined, the X content type, header is not set, and the Apache 2.0252 appears to be outdated. The flaw generalization was the following: if the vulnerabilities presented in the scan are not properly secured, a CRSF, cross-site scripting, and server attack could happen. To avoid click jacking, it is required to ensure that your site is not wrapped in an iframe by a malicious site by telling the browser to only accept instructions from HTTP headers or using JavaScript, also known as frame killing. To prevent cross-site scripting attacks, all the variables in the web application need to be protected with validation and sanitized to prevent injections. To prevent an Apache server attack, Apache should be updated from Apache 2.0.54 to at least Apache 2.4.37. Support for Apache 2.2.34 and older has been discontinued. The next vulnerability tool scan that I used was OWASP ZAP. The following the flaw hypothesis methodology using OWASP ZAP was the following. The goals of the penetration testing were to understand the OWASP ZAP vulnerability scanner tool. The background study was searching for those vulnerabilities of the Keyoptrix level 2 machine using the OWASP ZAP and targeting the Keyoptrix level 2 IP. The flaw generation was using OWASP ZAP to gather information about the target host. The flaw confirmation was the following: SQL injection, absence of anti-CSRF tokens, content security policy header not set, missing anti-click jacking header, server leaks information via X powered by HTTP response, and X content type options header missing. The flaw generalization is that if the vulnerabilities presented in the scan are not properly secure, a CRSF, cross-site scripting, and server attack could happen. Setting the CSP header adds a layer of security that protects and mitigates cross-site scripting and any other injection attacks. Another solution is to return the X-frame options or content security policy HTTP header with the page's response to prevent the interception of the HTML tags. The solution to prevent server leaks is to ensure that your web server application and the load balancer are configured to suppress X powered by headers. The next vulnerability scan tool that I used was Nessus. Nessus was my favorite because it gives you a more user-friendly interface, and it was able to tell you the score of the impact of that vulnerability. Therefore, I enjoy using Nessus the most. The flaw hypothesis methodology for Nessus was the definition of the goals of the penetration testing was to learn and understand the Nessus vulnerability scanner tool. The background study was to use the Nessus to enumerate the Q-Objects level 2 machine by targeting it with the IP address. The flaw generation was to gather information by scanning the target host. The flaw confirmation was the following: insecure SSL version 2 and 3 protocol detection. TLS has a number of cryptographic design flaws. SSL drown, attack vulnerability, browsable web directories, web application vulnerable to clickjacking, open SSL vulnerability, Unix operating system unsupported version detection, and PHP unsupported version. The flaw generalization was that if the vulnerabilities presented in the scan are not properly secure, a CRSF, a cross-site scripting, and server attack could happen. Flaw elimination could be taken by the following way. For the operating system vulnerability, we have to upgrade the Unix operating system from CentOS Release 4 to CentOS Stream 7 for better security, since Release 4 has been discontinued. For the SSL vulnerability, SSL 2.0 and 3.0 should be disabled and replaced by TLS 1.2 or higher instead. To prevent SSL drown, SSL version 2 should be disabled and a cryptography cipher suite should be used. To prevent browsable web directories, access restrictions should be enabled and directory indexing disabled. To prevent open SSL attacks, you should upgrade it to OpenSSL 0.9.8Q-1.0.0C or later. To prevent PHP attacks, you should upgrade it to PHP version 4.4.2 or later. My hypothesis is that the proper security measures should be implemented in a network system to minimize the attack surfaces with the hopes of preventing a cyber attack. The security measures include upgrading the operating system, using stronger cryptographic protocols, installing CRSF guard, implementing content security policy, HTTP header with responses, upgrading the PHP to version 4.42 or later, and updating the Apache server to at least version 2.4.37. The vulnerability map analysis of the Q-Objects level 2 system is as follows. The first one, absence of anti-CRSF tokens. Second one, cross-site scripting. Third, content security policy header not set. 4, browsable web directories. 5th, insecure SSL version 2 and 3 protocol detection. And 6, open SSL vulnerability. The first one, the cross-site request forgery, CSRF, is an attack that forces a victim to send HTTP requests to the target without their acknowledgement. A CSRF attack exploits the website trust with the user, and the attacker takes advantage of this vulnerability by performing session writing repeatedly without the victim's knowledge. The second one, the cross-site scripting, is a malicious script injection attack on a trusted website. When an attacker exploits this vulnerability, they can send and execute malicious scripts to the victim, and they can deceive them by believing that the script comes from a trusted source. For the third one, the CSP header not set, if you correctly configure the CSP, this is an added layer of security that protects and mitigates cross-site scripting and any other injection attacks. For the fourth one, browsable web directories, ensure that browsable directories do not leak confidential information or provide access to sensitive resources. Use access restrictions and disable directory indexing. For the fifth one, SSL 2.0 and 3.0 should be disabled and replaced by TLS 1.2 or higher. For the sixth one, data must be encrypted with the most robust cryptographic keys to ensure the protection of confidential data such as usernames, passwords, social security numbers, and credit card numbers, and to prevent any sniffing of critical information. Your company should implement the use of the most secure TLS methods such as elliptic curve, Diffie-Hellman, elliptic curve digital signature algorithm, AES 256 in Galois counter mode, and SHA 384. The application of tools and techniques in this lab was the following. The way I would apply the tools and techniques to identify vulnerabilities is by first employing a vulnerability assessment of the following organizational components: host, network, and wireless, database, and applications. I would separate them in these categories to identify each of their critical vulnerabilities. Second, I will perform a vulnerability analysis to find the source and the root cause of the vulnerability found in the assessment. This will provide a better understanding of how the vulnerability can be repaired. Third, I will perform a risk assessment to prioritize vulnerability by their impact on the organization. I will take into consideration systems, data, business functions, severity, and potential damage. Fourth, I will remediate and mitigate the identified vulnerabilities. The techniques that I used to trace the vulnerability were the following: the OWASP ZAP and Nikto to assess probable issues and understand attack patterns. Nikto and OWASP ZAP are open source web vulnerability scanners, and I also utilized Nessus, which is a patented web vulnerability scanner developed by Tenable Network Security to trace a vulnerability. The attack vectors for SSL vulnerability were the following: advanced persistent malware, man-in-the-middle attacks, phishing scams, expired SSL, TLS certificates, and attacker encrypted communications. Researchers, when should a vulnerability be disclosed to the public? I believe that researchers and developers should disclose vulnerabilities by following the vulnerability disclosure process. First, discover the vulnerability. Second, develop a vulnerability report. Third, investigate and patch the vulnerability based on the report. And fourth, publish a vulnerability analysis. The latter one should include the explanation, impact, and resolution of the vulnerability. In my opinion, vulnerabilities should be disclosed to the public as soon as the developer or owner of the application found out about them. They should disclose it as soon as possible to alert the users of the applications about the issue and seek a resolution to prevent any attacks on said vulnerabilities. I chose the SSL vulnerability, and I believe that the root cause of SSL vulnerability is the absence of cryptographic protocols at the transport level and SSL TLS handshaking protocols to protect sensitive company information being sent over the internet infrastructure. Thank you very much for listening. Have a good one.